Hello class. Well, as today is catch-up day, you've been doing transformations and you'll see that there was a third worksheet called Transformations 3. So in place of me being there to answer your questions and everything, what I thought I'd do is just do a video of me taking up each and every question. So obviously I'm not going to make you watch this entire video. You could fast forward to the places that you had difficulty with. So my suggestion is that you give all the questions a try and then play this video, finding the parts that need a little bit more explanation to help you find success in doing them. And so I'm just going to jump straight in. I might go at speed, but you know you can pause and replay if you like. Okay, so let's go with the first one, factoring. So when we're factoring, we're looking for a greatest common factor first, and the greatest common factor between the different factors of each term. So I'm first of all looking at the factors of the numbers. So 8 and 32, greatest common factor is 8, so I can put equals 8. And then I've got between the let me get my highlighter set up here. Okay, between the x and the x squared, the greatest common factor is the smallest exponent there. And then between the y and the y squared, again it's just y. And the z only appears in one term, so it's not common. All right, so then I can start my brackets. And how do I get 8xy to become 8xy? Well, just multiply it by 1. That's it. And then we've got minus, and 4 8s are 32, so it's 4. X times x will give me x squared. Y times y will give me y squared. And then we need a z squared to be included as well. And so that's it. That's all we can do. Nothing else we can do with that. All right, next question. Marcus and his friends are having a party. Marcus buys 5 burgers and 9 sodas for $28.75. I think that's important. The beefy burger joint. When 5 more of his friends show up, he heads back for 10 more burgers and 10 more sodas and spends $47.50. How much do burgers cost and how much do sodas cost? Okay, this is an example where I've got two statements with 2 variables, and our variables are the questions asking how much the burgers cost and how much the sodas cost. So let's define our variables first. So we'll let B represent the price of a burger, price or cost of a burger. And I'm not going to use the letter S for sodas, I'm just going to use A, okay? Represent the price of a soda. So now I have my 2 variables. All I'm going to do now is, let me just move these questions down for a bit. Hopefully I'll have room for them later. Oh, they're really not playing today. Let me undo that. I don't know where question 3 went. Oh, there it is, it's hiding. Okay, we're just going to translate these 2 statements here, this one and this one, into equations. So let's start with this one, equation 1. So equation 1 will be 5 burgers and 9 sodas. So 5 burgers, so 5b, plus 9 sodas, 9a, will equal $28.75. And then equation 2, which is 10 sodas and 10 burgers. All right, so 10 burgers plus 10 sodas equals $47.50. Right, I could do elimination or substitution. Substitution is real difficult. I'd have to isolate one of the variables, which will leave me with fractions, which I don't want, or really not nice numbers. I guess number 2 could do it, but I prefer to use elimination anyway. So I'm going to take equation 1, take a look at it, and see that my coefficient of b can easily be the same if I multiplied everything in equation 1 by the number 2, because multiplying 5 by 2 will give me the 10 that I need to eliminate. So let's do 2 times equation 1. So I'm writing my thinking here. So therefore I have 10b instead of 5b. I have 18a instead of 9a, and 28.75 times 2, it's a bit late for me to be doing that in my head. 28.75 times 2 is 57.50. All right, and then I'll just rewrite equation 2 out again. 10b plus 10a equals 4750. And now I really don't have enough room, so let me see if I can just get this moved. Yeah, whoops. This really is not working for me today. What's going on here? There we go. Whoops, indeed, no. Having a bad time of it with these questions being in the way. Okay, now what we'll do is, because we have the same sign in front of that 10, they're both positive, I'm going to subtract. So 10b minus 10b disappears, so that's gone. And then we have 18a minus 10a, which gives me 8a. And 5750 minus 4750 gives me exactly 10. So my a equals 10 divided by 8. And 10 divided by 8 in money terms is $1.25. So a equals 1.25, which makes sense. Price of a soda, that looks good to me. And now we're going to sub this back into either equation. I'm going to use equation 2, I think. So sub into 2. Typically I pick the one with the smaller numbers, but 10 times $1.25 is much easier to do in my head. So therefore we have 10b, that's the price of the burger, plus 10 times 1.25 equals 47.50. Now just simplify. So 10b plus $12.50 equals 47.50. Now we'll subtract 12.50 from both sides, so that will give me 47.50 minus 12.50, and which will give me 37.50, 37, 36, 35, I believe. So 10b is 35, so therefore b equals 35 divided by 10, which is 3.5 or 3.50 if we're doing dollar amounts. So therefore a soda costs $1.25, whoops, and a burger costs $3.50. All right, and that's it. Okay, number 4. Let me just grab hold of these and move these. Oh, not number 4. We're doing number 3 next. Let's do number 3. Okay, this one. Find the vertex of this and sketch a parabola. So you can use that nice little shortcut method I told you about to find the axis of symmetry. X equals negative b over 2a. Or you could factor it. It's up to you. This is my a, my b, my c. So x equals negative b over 2a, which is negative 4 over 2 times 1, or 2, which is negative 2. So this is the x value of my vertex. So now to find the y value, I can just sub it in. So the y value of my vertex is just y equals x squared, so negative 2 all squared, plus 4 times negative 2 minus 21. You can just put this in your calculator or do it in your head. I'm going to do it in my head for now. And that will give me negative 25. Whoops. Negative 25, I believe. Okay, and so the vertex is negative 2, comma negative 25, and we want a little sketch of the graph. Okay, what's that going to look like? So let's do a little sketcheroo. We have, and it really has to, it can just be a sketch. Negative 2, negative 25, so I'm going to put my x-axis quite high up this time. Arrows on both ends. Negative 2, negative 25, so let's just label that down here, like something like that. Negative 2, negative 25. We've got our y-intercept is negative 21, so we can mark that up, negative 21, kind of mirror it, sort of. And that's it. Now, we've only got 3 points, so maybe we do need to factor it to find the zeros. Is it factorable? I don't know. I think it is. So we can certainly factor it to be x. I think it's going to be plus 7 and x minus 3, because 7 times 3 is 21, and plus 7x minus 3x gives me the 4x. So I have my zeros at x equals negative 7 and x equals 3. So we can put that on there, so we can have zeros at negative 7 and 0 at 3. like that. So this is just a sketch, right? So you're indicating your values on there. We know it's opening up. We've got our y-intercept, we've got our zeros. So y-intercept, we've got our zeros, and we have our vertex labelled. And we have 5 points, so that makes me happy. All right. Next question. Is the point -1, 13 on the parabola? This one's a super easy one. All we need to do is remember that this is an x value, this is a y value, and we're looking to see if those two values make this equation true. So let's do a left side, right side check. And in fact, I'm just going to use the x value, I think. So my left side is just y. So let's see if that evaluates to what we need with a right side. So my right side is x minus 1 all squared plus 5. And with x equals -1, that means -1 minus 1 all squared plus 5, which is -2 all squared plus 5, which is 4, because -2 times -2 is +4, plus 5, which equals 9. So when x equals -1, y will equal 9. Now remember, this is a parabola which has a vertex of what? 1, 5. 1, 5. Okay, so 1, 5 is kind of like there, and it's opening up. When x equals 0 is 6, so it's kind of like that. Okay, kind of like that. And does it make sense that when x is -1, y is 13? Probably not. Definitely makes more sense that it is 9. And you can see that from a little sketch too. Okay, but you know that for a quadratic relation, for any x value, there'll only ever be one y value. All right, so this will mean that no, the point is not. The point -1, 13 is not on the parabola. And there we go. All right, let's do question 5. And I think I might be out of space, so I might move question 7 on to the next page in a minute. Find side C to the nearest whole number. You may use a calculator for this question. All right, so let's do that. Side C. Side C is right here. It's opposite angle C. I have angle C. What else do I have? I have 2 other sides. Do I have any other angles? No. So I have what we call a side angle side, which is indication to use cosine law. So to find cosine law of a missing side, let's set it up with the side squared, which equals the other 2 sides squared, added together, just like Pythagorean theorem. But then we have this addition, which is minus 2ab times cos of the angle between, 41 degrees. Okay, my A is 29 and my B is 13. Not that it really matters with this, because it would make a difference to the calculation in this case. Minus 2 times 29 times 13, but you want to make sure they're in order anyway, in case you move on to use sine law to find maybe an angle afterwards. Okay, now put this in your calculator all at once. Please do not split it up, otherwise you will make a mistake, or more likely to make a mistake, should I say. Times 13, whoops, I just made a mistake in my calculator, times 13 times cos of 41. And that gives you approximately 440.94898. And now we're going to square root that. So therefore, whoops, C equals the square root of that. And I'm showing my work. 94898. It's okay to list it to 6 decimal places. But then keep it in your calculator with the full decimal places shown. And square root that, and it's to the nearest whole number, so that is approximately 21. We don't have any units, so we'll just write the word units. And that's it. Okay. All right, number 7, and I think maybe we'll move that onto the next page because I'm kind of running out of room a little bit. Yeah, I'll move all these down a little bit. Okay, here we go. Let me just cut that and paste it on the next page. All right, the zeros of a quadratic are 3 and -5. Find the equation if it passes through the point 1, 24. So I know that the zeros of a quadratic means I can easily write it in factored form. So in factored form, my equation looks like y equals a. Now we don't know the a value yet, but we do know x minus the first 0, which is 3. And then x minus the second 0, which is -5. So minus -5 becomes +5. And now we've got this extra information that it passes through this point, so we'll just use that to sub in. Sub 1, 24 to find a. I'm communicating what I'm doing. Therefore, so in place of x we have 1, in place of y we have 24. So we have 24 equals a bracket, and then we have x, which is 1, whoops, wrong color, 1 minus 3 bracket 1 plus 5, like so. And now let's simplify. So therefore 24 equals a bracket -2 bracket 6. Now remember multiplication, so let's multiply this -2 and 6 together, which gives me -12, and I'll put that at the front of a because typically that's what we do. And now we can get a on its own just by dividing both sides by -12, and therefore a equals -2. We're not quite finished yet because it did say find the equation, so we'll go back to our original equation up here, up here, and then we can just write it out with the a value as -2 and keep the rest the same. And that's it. Done. Okay, number 8. Compare questions 6 and 7. How are they similar or different? In question 6, since you were given the vertex, it's easier to find vertex form. I don't think we did that as question 6. Where was question 6? Did I even do question 6? It disappeared on me. I guess we should do question 6. Okay, let me go back and take a picture of that. Oh yeah, we didn't do question 6. I must have lost it. Let's do that now. Sorry, folks. And here's me thinking I was all organised there. All right, I will just slip question 6 in above question 7. Just move everything down a little bit. There we go. Sorry about that. Question 6. Whoops. I think actually I can just paste it. Paste. There we go. The vertex of a quadratic is 5, 4. Find the equation of the quadratic if it passes through 7, 2. Okay, vertex meaning we can get it in vertex form. This is my h value, this is my k value. Remember, with vertex form, y equals a bracket x minus h squared plus k. So let's substitute that in. So therefore, y equals a bracket. We don't know a, remember? We've got x minus the h value, all squared, plus the 4. And now we're going to sub in that point that we have. So we sub in 7, 2 to find a. You can see already that this is very similar to the one we just did. So therefore we have, in place of x, we have a 7. In place of y, we have a 2. So we have 2 equals, I'm just copying out this equation above now, just replacing my x's and y's with our given values. So 7 and then minus 5 squared plus 4. Simplify that, so we have 2 equals a bracket 2 squared plus 4. And 2 squared we know is 4. So we have 2 equals 4a plus 4. Now we need to get a on its own, so we'll subtract 4 from both sides. 2 minus the 4 is -2 equals 4a, and then we have therefore a is equal to -2 divided by 4, or -1/2. And so the equation that we need is y equals -1/2. All I'm doing now is putting the -1/2 back in place for this a. -1/2 x minus 5 squared plus 4. Nothing else changes, just copying it out. Okay? And now we can go to question 8. How are they similar and different? Question 6, since you were given vertex, it's easy to find the vertex form. Question 7, you were given the zeros, it's easy to find factored form. In both questions, you were given a point to find A. And we use substitution to figure out that. Okay, number 9. I think we need another piece of paper. And I'll just get rid of that one. Cut it. Cut. Okay. And paste. Maybe I'll have enough room in a minute, but we'll see. Simplifying this. Okay, there's lots going on here. So to simplify it means we've got to get rid of those brackets. So we're looking for simplifying what's inside the brackets first. Nope, nothing to go there. And then we look for following BEDMAS, so we have exponents. Exponents outside the brackets affect everything inside. That's each factor of everything inside. So this ends up being essentially, I mean, you don't have to write this up if you don't want, but it would be this 4 raised to the exponent 2. And then the x cubed raised to the exponent 2. And the y to the 8 raised to the exponent 2. We can do that because there's only one term inside here. There's no... There's not more than one term. There's nothing being separated by a plus or a minus, okay? If that was the case, we'd have to do something entirely different. And then let's just rewrite the second one. Okay? And then let's simplify these exponents as well. So we have 4 squared. That simplifies to 8. No, it does not. That's not 8, Mrs. Hooker. 16. X cubed squared. So raise a power to a power, multiply. So 3 times 2 is 6. And then y to the 8 to the 2 is y to the 16. Then we have times 2x, y to the negative 5. Okay, so now let's multiply the various factors together. 16 times 2, which is 32. And then we have x to the 6 times x. Remember, there's an invisible 1 on that exponent. When you multiply that basis, you add exponents. So that would be x to the 7. And then, last but not least, is y to 16 times y to the negative 5. Now, you might be asking me, why didn't I simplify that y to the negative 5 and make it a positive exponent? Well, I could see that there was something coming up in the works, as you will, here. I knew that there was going to be something multiplied, so I was going to leave that to the end if it needed to be done then. When you multiply like bases, you add exponents. 16 plus negative 5 is 11. So it'd be y to the 11. I'm happy with that. All my exponents are positive, and that's the end answer. Done. Okay? And I think, you know what? I think maybe I can fit a question 10 on here, maybe. No, I won't even bother trying. Let's cut that. Okay, question 10. Find the equation of the quadratic below given the graph. List the transformations from the base function y equals x squared. This is sometimes called the parent function as well, right? This is called the parent. You'll hear all about that in grade 11 if you do university level. And list the transformations that we use to make the graph. Okay, find the equation first. What do we know? Do we know the zeros? The zeros are nasty, so I don't think we'll be able to go for factored form. And it definitely wouldn't go for standard form. We don't even know the y-intercept. But we do have this. We have the vertex. And I would say the vertex is at 3, negative 5. So I know straight away I can do y equals a. We'll determine that in a minute. And then x minus 3 squared minus the 5. Okay. Now, could we use step pattern? I'm thinking we could. Let's go over 1 and up till we get to the next point. It looks like we're going up 2. But let's just check. If my first step was 2, then my second step would have to be 6. Because remember, the step pattern goes A, 3A, and then 5A, etc. Okay? So the next one would have to be 6. Let's see if it is. Over 1, up 1, 2, 3, 4, 5, 6. I think it's close enough. I think we're good. I think we've got our A value is 2. So I would definitely say that y equals 2 bracket x minus 3 squared minus 5. Okay. So, what transformations were applied to the base function y equals x squared? Well, we've got the a value, which is 2, which creates a, so a value equals 2, that creates a vertical stretch. And when we say vertical stretch, that means the y values have changed, right? The vertical stretch by a factor of 2. And then we have our h value of positive 3. So the h value is 3, and that means we have a horizontal shift, or you could just even say shift right, 3 units. And k value is -5. That means a shift or a vertical shift down 5 units. And notice that when we're talking about transformations, we're using positive values here, right? Positive values all the time. And then we just distinguish between them being like a -5, it would be a down, right? If it was +5, it would be up, all right? And that's really all there is to it. I think that's it. Yeah, I don't know why it says 11 questions here. I think for some reason there must have been a question that was taken out, but we never fixed the answer key. So my apologies about that. Hopefully that's helped. It's a little bit of a long video. Not helped by my technical skills not quite being up to par. But yeah, there you go. Homework take up. All right. Hope you had a great day and have a lovely weekend. And take care. Bye.